Hello Year 12 and welcome to the 7th video here for our first topic of the HSC year. In the previous exercise 106 we were looking at straight line depreciation, which is a method of modelling the decreasing value of some goods or asset over time. Okay, it's depreciation, and it went down by the same amount every term, let's say every year. Today we want to look at a different model. Now this model has some advantages over the straight line method. One of which is that it shouldn't ever take the salvage value into negative territory. Okay, that's a good thing. It decreases, it gets very close to zero, but never becomes zero or never becomes a negative number. Okay, so that's an advantage. I suppose the disadvantage of declining balance might be that it's a little more complex. Okay, because it is essentially an exponential function, which means that we need to use indices or exponents, powers of numbers to calculate them, and some people find that a little trickier. Anyhow, this is called the declining balance method. The abbreviations are very much the same as they were for straight line depreciation. Namely, capital S represents the salvage value, the value of this goods or asset at some point in the future. V0 is the initial value of those goods or asset. R, in this case, is the rate of depreciation, different to the amount of depreciation, that capital D that we used last time. This time it's likely to be a percentage. So we'll express R over 100 in the same way that we've had a rate of interest for simple and compound interest. And N is the number of terms. I think it works best, as usual, to jump into an example and see how that works. So example 14 here. Eva purchased a new car 2 years ago, $32,000. If it depreciates by $2,500 each year, find the current value. Now, if it depreciates by $2,500 each year, right, that is straight line depreciation. Okay, so we're not going to use this formula for part A. Right, it's going down by the same amount each year. So we can use our formula. Our salvage value is equal to our initial value, 32,000, minus that depreciation amount, 2,500, multiplied by 2 years. I think we can do this in our head because 2 lots of 2,500 is 5,000. 32,000 minus 5,000 is going to be $27,000. There we go. So that's part A, but what if the value decreases by 15% each year? It's going down by a percentage each year. We're talking about declining balance, depreciation, and we're going to use this new formula. So our salvage value now is equal to our initial value, 32,000. This time outside of 1 minus our rate, 15 over 100. To the power of N, right, which is just to the power of 2. Now I need to pull out the calculator because I don't want to do that one in my head. Here we go. Drag my calculator over the side. We can see what's going on here. And I have 32,000. Does this work? Oh, maybe it won't. 32,000 outside of 1 minus 15 over 100. Sorry for the view of the top of my head. Rapidly balding head there. To the power of 2. There we go. Now you can see what I'm going to type into my calculator has been written on my page, and what's written on my page is what appears on the screen of my calculator. That's very important. Right, pause for a moment. Consider, is what's on my screen the same as what I've written down there? I'm pretty happy to say yes it is. Equals, and now we find 23,120 is my salvage value. 120. Okay, so that's using both straight line and declining balance depreciation to estimate the salvage value of the car 2 years in the future. Now I have one more example here before we're done with depreciation. Angus buys a car, depreciates at a rate of 26% per annum. Right, that's quite a lot straight up, and frankly, a new car, that's not that unusual. After 5 years, the car has a salvage value of 17,420. How much did he pay for the car? Well, this is all sorts of complex, isn't it? Let's have a look. I do know the salvage value. That's the interesting part here. 17,420. I know my salvage value is equal to, well, I would put my initial value in here, but I don't know. So I leave that with a pronumeral, V0, outside of 1. Oh, come on. Oh, what's happening to my stars here? Oh, draw. Sorry. Outside of 1 minus, I rate 26 over 100, to the power of 5. Okay, we've got that expression there. This is not a straightforward type into your calculator. I'm going to have to make V0, my initial value, the subject of that equation. I'm going to do that by essentially dividing by this whole term here. Okay, and that's going to look like this. V0 equals 17,420 divided by, or over, bracket 1 minus 26 over 100 to the power of 5. Right, now that's going to work it out for me. I'm looking for an answer that's a bit more than 17,420. In fact, a pretty good bit more than that. So, thank you, calculator. Here we go. And let's have a go. We should be able to type that in so it appears just very much like we've written down there. So let's give that a go. I've got 17,420. The limitations of a small screen here. 17,420 over, bracket, 1 minus, is it 26 over 100, across here, bracket, to the power of 5. Okay, really important that what's typed in there closely matches the expression that we wrote down. Okay, it's fairly easy to get that wrong, to multiply by 5 instead of raising it to the power of 5 or something like that. So be careful, pause, have a look, make sure that you have typed that in correctly, because certainly you'll see me making that mistake from time to time. Okay, equals, and we end up with 78,503. So how do you like that? We started, that's telling us that the car new was worth 78,500, thereabouts, and now it's only worth 17,000, 5 years later. Sadly, people, that can be how it goes, right? Particularly with sort of prestige cars. Often the value will fall away quite quickly because there's a smaller market for a second-hand car there. So, come back to this, reading carefully to the nearest dollar. Okay, back to that, was it 78,504 to the nearest dollar is 78. Oh, come on. 78,504 to the nearest dollar is our initial value. Okay, that's it for depreciation. In today's exercise, we've looked at declining balance depreciation, where we're declining by a percentage each year, and we use a formula that looks, frankly, a lot like the compound interest formula. You can expect to be provided with a formula sheet anytime you have an assessment task, and when you're in class, I would encourage you to have your notes, booklets, and perhaps a formula sheet close at hand too, so you can refer to these formulas. You will be provided with them, you don't have to commit them to memory. Okay, but you do need to know how they work, and for example, this example 5 has been complicated in a way by asking us to calculate the initial value rather than the salvage value. Okay, that's it for the video. You know, if you've got any questions, it's best to write them down so you can remember them, to ask your teacher in class. Ask your teacher, and that might be me, it might not be. You're welcome to ask me anyway. See you next time.